Have you ever wondered what a black hole is and how it works? If so, you're not alone. Black holes are one of the most fascinating and mysterious phenomena in the universe. They are regions of space where gravity is so strong that nothing, not even light, can escape. They are invisible to our eyes, but we can detect them by observing their effects on the surrounding matter and light. In this documentary, you will learn about the different types of black holes, such as stellar, supermassive, and primordial. You will also discover some of the amazing phenomena that occur near black holes, such as gravitational lensing, accretion disks, and jets. We will also explore some of the unsolved questions and paradoxes that black holes pose for physics, such as the information loss problem, the firewall paradox, and the holographic principle. We will also examine some of the most intriguing questions about black holes, such as how do they form and what happens inside of them, how do they grow and die, and lastly, what can they teach us about the nature of space and time. Let's start with how do black holes form exactly. Black holes can form in different ways depending on their size and origin. There are three main types of black holes: stellar, supermassive, and primordial. Stellar black holes are the most common types of black holes. They form when massive stars run out of fuel and collapse under their own gravity. The core of the star becomes so dense that it creates a singularity, a point of infinite density and zero volume. The singularity is surrounded by an event horizon, which is a spherical boundary that marks the point of no return for anything that crosses it. The event horizon has a radius proportional to the mass of the black hole, and is also known as the Schwarzschild radius. Stellar black holes have masses ranging from a few to tens of times that of our Sun. They can be found throughout the galaxy, often in binary systems and with other stars or planets. When a star orbits close to a black hole, it can lose mass to the black hole through a process called accretion. The accreted matter forms a disk around the black hole and heats up due to friction and magnetic fields. The disk emits intense radiation that can be detected by telescopes. Some of the most famous stellar black holes are Cygnus X1, V404 Cygni, and XTE J1650500. On the other hand, supermassive black holes are considered the largest and most powerful type of black holes. They have masses ranging from millions to billions of times that of our Sun. They are believed to exist at the center of most galaxies, including our own galaxy, the Milky Way. They play a crucial role to the formation and evolution of galaxies as they influence the surrounding gas, stars, and dust. The origin of supermassive black holes is still a mystery. Some scientists think they formed in the early universe from the collapse of massive gas clouds or clusters of stars. Others think they grew over time by merging with other black holes or by creating large amounts of matter from their environment. Supermassive black holes can also produce enormous amounts of radiation by accreting matter from nearby stars or gas clouds. The radiation can form jets that extend for thousands of light years from the poles of the black hole. The jets can interact with the surrounding medium and create shock waves, bubbles, and lobes of hot gas. The radiation in jet can also affect the star formation and evolution in the host galaxy. Some of the most famous supermassive black holes are Sagittarius A, which is at the center of our very own galaxy, the M87 black hole, which is the first black hole to be imaged directly, and quasars, which are considered the brightest objects in the universe. Lastly, primordial black holes. Primordial black holes are hypothetical type of black holes that may have formed in a very early universe shortly after the Big Bang. They could have been created by fluctuations in the density of matter or by quantum effects during inflation. They could have any size, from microscopic to stellar or even larger. Primordial black holes have not been detected yet, but they could provide clues about the physics of the early universe and quantum gravity. They could also be candidates for dark matter, the mysterious substance that make up most of the mass in the universe but does not interact with light. So the question is, how do black holes work exactly? Black holes are governed by two main theories, general relativity and quantum mechanics. General relativity describes how gravity affects space and time around massive objects like black holes. Quantum mechanics, however, describes how matter and energy behave at very small scales, such as inside of a black hole. According to general relativity, a black hole has three main features: a singularity, an event horizon, and a photon sphere. The singularity is where all the mass and energy of a black hole is concentrated. It is a point of infinite density and zero volume, where space and time become infinitely warped and all known laws of physics break down. We do not know what happens inside of a singularity, as we need a theory that combines general relativity and quantum mechanics to describe it. The event horizon is where gravity becomes so strong that nothing can escape, not even light. It is also where time slows down to a halt for outside observer. Anything that crosses the event horizon is doomed to fall towards the singularity no matter what direction it moves in. The photon sphere is where light can orbit around a black hole at a constant distance. It is located at about 1.5 times the Schwarzschild radius of the black hole. If an observer were to hover at a photon sphere, they could see multiple images of the universe as light bends around the black hole. According to quantum mechanics, however, a black hole is not completely black, but it emits a faint radiation called Hawking radiation. This radiation is caused by quantum fluctuations near the event horizon, where pairs of particles and antiparticles are created and annihilated. Sometimes one of the particles escape the event horizon while the other falls in. This reduces the mass and energy of the black hole and increases its temperature. Hawking radiation is very weak for large black holes, but it becomes stronger for smaller ones. If a black hole loses more mass than it gains, it will eventually evaporate completely. Another question is, why are black holes important? Black holes are important for many reasons. First reason is they are the ultimate test of our understanding of gravity and quantum physics. Second, they are the source of some of the most energetic and spectacular phenomena in the universe, such as quasars, jets, gamma rays, bursts, and gravitational waves. Third, they are the key to unlocking the secrets of the origin and fate of the universe, as they may have existed before the Big Bang, and many determine how the universe will end. Lastly, they are the inspiration for many scientific and artistic work, such as books, movies, games, and music, and for the surprise, this very documentary. Black holes are also fascinating because they challenge our intuition and imagination. They pose so many questions, and some of the most important ones are, what would happen if you fall into a black hole? What would you see if you were near a black hole? Could you travel through a black hole to another place or time? Could there be other universes inside or beyond a black hole? Or could there be life around or inside a black hole? These questions may not have definitive answers, but they stimulate our curiosity and creativity. Black holes are not only objects of scientific inquiry, but also of wonder and awe. Now, here is some of the issues with black holes that are baffling scientists. The information that describe matter going into a black hole seem to get lost in the singularity, which acts as a firewall preventing us from understanding what's going on inside. Perhaps a theory of quantum gravity can help us decipher the mystery as stated in the holographic principle, with conjunction with Hawking radiation. At the moment, we can only speculate and use our wild imaginations, and one of these speculations is, what if a black hole is simply a recycling machine for the universe? Its purpose is to dismantle matter back into its constituent subparticles, such as bosons, and bring back the universe to its original state of disorder and equilibrium. But these are only speculations, and only time can tell, with technology and knowledge advancing more and more. Now, before this video ends, I will leave you with this beautiful sounds of black holes that are generated and put together by NASA. Enjoy. Thanks for watching the video. Please like and subscribe down below to help us grow the channel and make more documentaries like these.